This video is exercise 11.6, but we're just going through one homework problem. Exercise 11.5, question 10. It says R is the point on that parabola y squared equals 20x. When you see that, what type of parabola do you have? Y squared equals 20. Sideways one, turning to the right. And what's y squared is 4ax. What's the a is 5. So therefore, if we just did a quick sketch, so we've got R is the point, 1/5 negative 2. It's a point on the parabola y squared equals 20x. We know that parabola, so this is exercise 11.5, question 10. We know that that parabola looks like this, vertex 0, 0, and it turns to the right. This is of the type y squared equals 4ax, so 4a is 20, therefore a is 5. We know that the point 1/5 negative 2, which might be down here, this is the point R, 1/5 negative 2 lies on the parabola. It says find the equation of the focal chord passing through R. Were we able to do that? What's the focus? What's the focus? Well, no, it's 5, 0. The focus is over here. It's 5, 0. Equation of focal chord is the equation of the line passing through, I'll call that F for focus. It's the equation of the line passing through R and F. Okay? Do we know what to do there? Find the gradient, which will be y2 minus y1 over x2 minus x1. It's 2 over 4 4/5. Did anyone already work that out? 5/12 is the gradient. The equation of the focal chord, you will find it by using the point gradient formula. Y minus y1, I'm going to use that point. So I'm going to use gradient 5/12, and I'm going to use my point's going to be 5, 0. So y minus 0 equals the gradient m, x minus 5. So we get y equals, I'm going to take that 12 over there. Do they want it in? So we get 12y equals 5x minus 25. So basically I've put this 12 over to the other side, and then I get 5x minus 25. So you get 5x minus 12y minus 25 equals 0. That's the equation of the focal chord in general form. Now, it says find the coordinates of Q, the point where this line or the chord cuts the directrix. So where's the directrix at? Yeah, so it's at x equals -5. That's the directrix. This is the point Q. So all we know about point Q is that its x value is -5. And that point Q, so this is what we've got for part B. Point Q lies on the line 5x minus 12y minus 25 equals 0 and has x coordinate of -5. Do you agree? Q lies on that line and its x value or x coordinate is 25, is -5, sorry. So we're going to substitute x equals -5 into the equation of the line. Does this make sense? Because then you'll find its y value. And we get 5 times -5 minus 12y minus 25 is 0. What do you get? Take the 12y to the other side. -50. Y is -50 on 12, which is -4. No, it's negative. Because it's -50 divided by 12. -4 and 2/12, or -4 and 1/6. Okay, now, so therefore Q has coordinates -5, -4 and 1/6. See, girls, it really helps to do a sketch. You do a sketch, like up here, you can see that Q has got a -x and a -y value. All right? So we've got the coordinates of Q. Okay, you have to find the area of triangle OFQ, where O is the origin. All right, we come back up here. Actually, I'm going to draw the triangle again. Yeah, C. All right, I'll draw it again. We've got Q is down here at -5, -4 and 1/6. I know I'm off. We want O, F, focus is 5, 0.
Yes.
Yeah, I know I'm off.
No. Shouldn't it be positive? 12y equals positive 50.
No, because if I take this 12y over to the other side there, I get -25 minus 25. I get -50. So girls, we need the area of this triangle. Right. Well, oh yes, we can do that. Girls, you can do. Girls, there are 3 types of triangles that you learn in Year 7. So with this last one, we're looking at this type of triangle where the perpendicular height is located outside the triangle, and that will happen for obtuse angled triangles. So the base will be the base, but the perpendicular height will be outside the triangle. Here, we can see that the base is 5 and the perpendicular height is this length. Now, this is the point -5, -4 and 1/6, so this length is 4 and 1/6. So therefore, the area is a half of 5 times 4 and 1/6, which is, it's 10 and, anyone? 10 and some? 10 and 5/12? Yeah. Is that what you got on your calculator? Yeah. 10 and 5/12 units squared, please. You need to put units squared. Do we have that, girls? So we've got this type of triangle. The perpendicular height is outside the triangle. As long as height, perpendicular height and base are at right angles to each other. All right? Are we done? Okay, so we've done that. Find the perpendicular distance from the chord to the point -1, -7. There's your chord. All right, I'll just move this page. We ready? So the next bit says, that was C, we have to find the perpendicular, part D, find the perpendicular distance from the chord to the point -1, -7. I'll say that's down here somewhere. Here's the point -1, -7. It's the I might have to do another diagram. So part D, wait a sec, the chord goes like this. The chord goes 5, 0 down to -5, -4 and 1/6. We want the distance of -1, -7 to the chord. That would be the perpendicular distance, yes? All right, do you know what we're doing, girls? Find the perpendicular distance of the point -1, -7 to the chord. What's the equation of the chord? The equation of the chord is 5x minus 12y minus 25 equals 0. So what do I do? Perpendicular distance of a point to a line. Do you know the formula? D equals absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. The ax1, the axbyc is just the equation of the line, and the x1, y1 is the substitution of the point into the x and the y value of the line. That's what the x1, y1 are. So it's 5, substitute in the x value, -1 times -1, minus 12, substitute in this y value, -7, minus 25, so the absolute value of all of that over, these are a and b, so it's over 5 squared plus -12 squared. Hi, Christy. So we get absolute value of -5 plus 84 minus 25, so that's -30 plus 84. Okay, positive 54 over, isn't this 13?
Yep.
It's a triad. So it's 54 over 13, which is, it'd be nice if it was 52 over 13. 4 and 2/13. So that's the perpendicular distance of the chord to the line. And then the last bit is part E. Hence find the area, what's this point called? Hence find the area of PQR. This is the point P, that's Q. R, is that Q? Oh, R is on the parabola. R is 1/5, negative 2 up here. No, negative 5th, negative 2 is on the line. Negative 5th, negative 2 is definitely on that line because I've just looked up at the picture. So there's R, negative 5th, and negative 2. So we need, oh, look, we're lucky because it's a right angled triangle. And we just found this distance there. See, we've just, but we don't know where it touches the line. You don't know where this touches that line. It doesn't necessarily hit it at Q. You don't know that. Yeah, you just know that it's the perpendicular distance of the point to the line.
We don't know what Q is, we know what
No, who said that it meets at Q? It doesn't meet at Q. We don't know that. Q's down there. It could hit here somewhere. It doesn't say it hits Q. So it's not the point. Girls, what you've got to be really careful with is that this perpendicular distance of the point to the line does not necessarily touch that line at Q. So we know this perpendicular distance is 4 and 2/13 units. We know we can find the length of the hypotenuse by using the distance formula. Okay? So we're going to use the distance formula to work out the distance PR. So PR will be distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. So what do we get? Let's do negative 1 minus...
this way, trying to find the hypotenuse.
Because I can't find this length. You know, you don't know that that's point Q is here.
But is that PQR? Yeah, PQR is the triangle.
Oh, sorry, ladies.
Because you meant to find
Back, go back. I didn't read the question. Okay, girls, sorry, I didn't read the question properly. So find the area of triangle. It would help if I read the question. All right, so girls, Q might actually be down here. We don't know that it's actually that point there. So the question is to find the area of triangle PQR. So you've just found the perpendicular height, which is 4 and 2/13. So we okay with that? Sorry, girls, I did not realise. Didn't read the question properly. So Q is this point here, negative 5, negative 4, and negative 4 and what, girls? Negative 4 and 1/6. Are we okay with that? So look, Q is down here somewhere. The perpendicular height is there. If we know the base times the perpendicular height, that will give us the area of the triangle. So, girls, I just didn't read the question properly. It's find the area of triangle PQR. So we need the distance of QR using distance formula, which is, what have we got? Anyone done it? We get negative 5 minus negative 1/5 squared plus negative 4 and 1/6 minus negative 2 squared. Did you do it? What did you get?
So it's D equals square root of 27 and 1 over 25 plus, I'll do the lines.
So you get square root of 27 and 1 over 25 plus,
4 and 25 over 36.
and then you get square root of.
I just did the answer is 5 and 19 over 30.
So we get that QR is 5 and 19 over 30. Sorry, girls. Sorry about the mess. So we know that QR is 5 and 19 over 30. Sorry about that. Therefore, the triangle, area of the triangle is half of base times perpendicular height, which is half of, the base is 5 and 19 over 30, and the height is 4 and 2/13. And you get, sorry? 11.7, exactly. Units squared. Sorry, girls, it would help to write the question down. That was triangle PQR. I should have read it correctly. Okay? What? Well, R is, no, it's -5 minus -1 on 5. It's x2 minus whatever x1 is. And x1 is, you are right. You are right. It's 1/5. You're right. And I think she did it like that anyway. That's fine. It's still, yeah, you're right, Angela. It's right. Okay, it is -5 minus 1/5. Sorry, that's the point, 1/5 -2. It works out to be the same thing anyway because, yeah, it's correct. Yeah. Yeah, it's 5 and 1/5 squared, which is 25, which is 20. Is it? Yeah. But I'm pausing it before I make it. 7, find the equation of the focal chord. We want the equation of the focal chord that cuts the curve y squared equals 16x at 4, 8. So this is y squared equals 16x, which is of the type y squared is 4ax, 4a is 16, a is 4. Which way does the curve go? That's how you can tell. Because this is 4, 0, and if you want the point 4, 8, it's directly above it. Yes, so therefore that is it's a focal chord, but it's also the latus rectum because it's perpendicular to the axis of the parabola, or it's parallel to the directrix. Okay? So to find the equation of that, it's just x equals 4. So equation of, basically it's the latus rectum, is x equals 4. Okay? Because the latus rectum is either we say it's perpendicular to the axis of the parabola, or you would know that it's parallel to the directrix. Okay? All right, I'm going to start a new video for exercise 11.6 examples.